Hi all, in this lecture we will see the weekly quiz 5 solutions. In this quiz we have questions from logical arguments in propositional logic and also logical consequence, or we can call it logical inference, or we can call it logical implication. All these concepts we have studied in the class. Okay, so now let's see the solutions. This is the first question in weekly quiz 5, and this question is saying that consider the following atomic propositions. So two propositions are given to you. This r comma s, these are the propositional variable. R represents it is running, s represents Sonu is sick. Which of the following is or are correct English translation of the following logical expression? This logical expression is given to us, and which of the following is correct logical translation? So this is MSQ question, means multiple options can be correct. So let's see. First, let's look at this expression. What is this expression? So this is a standard expression, R or S negation and R negation or S. So if we simplify, first you simplify and let's check what is this expression. So what we can do, we can simplify this using the rules of logic, using the rules of propositional logic. We can simplify this. So what we can do, we can do the distributive property. We can apply the distributive property. So okay, so it is actually easy. If you write like this, then it is easy, because you can use this symbol. This is the symbol for disjunction, or we can use this symbol for disjunction. So both are correct symbols for disjunction. Okay, so it is easy if we write like this. Now what is this, what this will become? Now you can apply the distributive property. So it will become r bar, okay, or rs, or s bar r bar, or s bar s. Now we already know that this is false, and we also know that this is false, and we know there's false or anything that is basically alpha. Okay, so from here I can say that it will become s rs or s bar r bar, and this expression, this is equivalent to r by implication s. So this we have already seen. This expression is equivalent to r by implication s. So remember, this is the given expression in the question, and this is equivalent to r by implication s. Now how can we read this? So we can read this in many different ways, like r if and only if s. Okay, so we can basically say that this is r if and only if s, or you can call it r is necessary and sufficient condition for s. Or okay, so there are many different ways in which we can read it, or we can say r implies s and converse. Okay, so r implies s and s implies r. So these are the different ways of reading this expression in the English. So what will be the answer? So here the answer will be, okay, R means it is raining, S means Sonu is sick. And remember, this expression is same as R by implication S. So finally answer will be, it is raining if and only if Sonu is not sick. This is not correct, because R by implies S. It means it is raining if and only if Sonu is sick. It is raining if and only if Sonu is sick. Okay, if Sonu is sick, then it is raining, and vice versa. This is correct, and vice versa. So this is correct, because vice versa means this is basically converse. I can say if Sonu is sick, then it is raining, and if it is raining, then Sonu is sick. So basically this means if Sonu is sick, then it is raining, and if it is raining, then Sonu is sick. And remember, this is same as, and remember that this is same as by implication r by implication s. It is raining is equivalent to, it is raining is equivalent to Sonu is sick. This is also correct, because r by implication s. So I can say that r is equivalent to s, because okay, this by implication means r implies s and s implies r, means they always have same truth value. R comma s, they always have same truth value. This is the meaning of r by implication s. So it is raining is equivalent to Sonu is sick. Okay, so this is also correct. Now, what is option A and option D? So option A is saying that it is raining if and only if Sonu is not sick. What is this? It is raining if and only if Sonu is not sick. Okay, so we already know this is equivalent to R exclusive or S. So the option 1, this option 1, this is basically R exclusive or S. Okay, but remember this given expression, this is R by implication S. So option A is not correct. And what about option D? It is raining or Sonu is sick, but not both. This is also R by R exclusive or S. Okay, so option D is R. Option D is basically R exclusive or S. Option A is R exclusive or S. Option B is R by implication S. Option C is R by implication S. So answer will be option B and C. Okay. Now let's see next question. So this is question number 2. P is a propositional variable. So this P represents a atomic proposition, because you remember this is saying that P is a propositional variable, and we have already seen that propositional variable represents atomic proposition. So basically this P, this represents atomic proposition. Which of the following propositions are tautologies? So because P is atomic proposition, okay, so this P is either true or false. Okay, because we have already seen what is atomic proposition. Atomic proposition is true or false by itself. Atomic proposition is not dependent on anyone else. So here P is a propositional variable, and propositional variable represents atomic proposition. So this P is a atomic proposition. So which of the following propositions are tautologies? So this is not a tautology, because P can be true or false. Okay, so this is not a tautology. What about option B? Tautology means always true. So let's see whether it is always true or not. Okay, remember P is a propositional variable. Now because P is a propositional variable, so I can call it alpha. Okay, so this alpha is basically P implies P. Okay, so this is a this is alpha. Now P is a propositional variable, so P is either true or P is false. Because remember P is a propositional variable, so it represents an atomic proposition. So that is the reason we are saying that P is true or false. Okay, because atomic proposition is true or false by itself. Atomic proposition is not dependent on anyone else. Atomic proposition is basically true comma false. Okay, I can say it is true or it is false. Now so P is true or P is false. There are two possibilities. Now in this possibility you can notice true implies true, that is true. And in this possibility, when P is false, then false implies false. We know that false implies false, this is also true. And true implies true, this is also true. So here we got true true. So you can notice that this is always true. P implies P, P implies P, this is always true whatever P you put. Okay, so whatever proposition P you put, whatever atomic proposition P we put here, this expression P implies P, this expression will always be true whatever statement P you put here. Okay, so this is the meaning. So this is a tautology. What about the next? Okay, the next is P implies P implies P. Now notice that this is true. Okay, P implies P. So actually you can apply this expression here. So we know that P implies Q, this is equivalent to P dash or Q. Okay, so you can just apply this will become P dash or P dash or P, that is basically true. So this is actually true, this is equivalent to true. I can say that P implies P, this is equivalent to true. Now what is true implies P? What is that? So I can again write it. I can use this expression P implies Q, that is P bar or Q. So I can say that this is true bar or P. What is true bar? That is false. So I can say that false or P. What is false or P? That is basically equivalent to P. So you can notice option C, that is simply equivalent to P. This option C is equivalent to P. I can say this is equivalent to P. So this is also not a tautology. Next, what is P implies? So okay, so the last one is P implies P. Now we already know that this is true. Okay, and anything implies true. P implies true, this is basically true, because in the implication anything implies true. Whatever you put here, that does not matter. Anything implies true is basically equivalent to true. Okay, so this option D, you can notice this option D is a tautology. So answer will, this is again MSQ multiple select question. So which of the following propositions are tautology? Answer will be B comma D. Okay, let's solve the next question. This is question number 3. Now which of the following, which of the okay, so actually this should be which of the following. Okay, so I can say that which of the following propositions, which of the, so which of the two following propositions are equivalent in the sense that one can be substituted for other one in any proposition without changing its truth value. So basically the question is asking which of them are equivalent. For example, this is the first proposition. Is it equivalent to the second proposition? So this is the question. Okay, so let's see option A. In the option A, you can notice that the first proposition is, in the option A, I can say first proposition is P implies Q and second proposition is negation P or Q, yes, they are equivalent. So I can say that they are definitely equivalent because P implies Q is equivalent to negation P or Q. Okay. Next, first proposition negation P, second proposition P implies false. So let's see option B. First proposition is negation P and the second proposition is P implies false. We already know that P implies Q, this is equivalent to P bar or Q. Okay, so here I can say P implies false. What that will become? That will be P bar or false, and this is same as P bar. So I can say that this is same as P bar. This is equivalent to P bar. So first proposition and second proposition, they are basically equivalent. Okay, next. Next, first proposition is P bar, second proposition is false implies P. So the first proposition is P bar and the second proposition is a false implies P. Now false implies P, this is actually equivalent to true because we already know false implies anything. You can put here anything that is basically equivalent to true. So I can say that this is P bar and this second proposition is equivalent to true. So they are not equivalent. So I can say that this option C is not correct. In the option D, P bar and the second proposition is P bar or Q. Of course, they are also not equivalent because P bar is not equivalent to, I can say, P bar. This is definitely not equivalent to P bar or Q because both are, they are not equivalent. You can very easily see. So I can say that answer will be option A comma B. Let's solve this next question. This is question number 4, and in this question, first of all, this definition is given to you. Let KB stand for knowledge base. This concept we have already seen in the class, and we have already seen what is a knowledge base. Knowledge base is basically set of premises. Okay, so for example, if I give you a knowledge base which is set of premises. If I give, for example, let's assume this is the knowledge base. Knowledge base means a set of premises, like for example P and Q, P implies Q. So let's assume this is set of premises. Then from this can we conclude something? From this can we infer some knowledge? So remember this definition we have already seen, that knowledge base is basically set of premises. For example, okay, so you already know that this is the symbol of logical inference. So we already have seen that this is the symbol of logical inference. And what it means, I can say that alpha infers beta. How do we read it? Remember, this we read like this: alpha infers beta. Okay, this is the how we read this. Okay, this is the, so this symbol is used for inference. So we can say this means alpha infers beta. Okay, and what it means, and what it actually means, alpha infers beta if and only if alpha implies beta is a tautology. Okay, so this definition we already know. This definition we have seen in the lecture. For example, you can notice that P and Q infers P. Okay, we know this. Why? Because if P and Q is true, then definitely P is true. So this is correct. This is correct. And why this is correct? You can easily see that P and Q implies P. This is a tautology. This is tautology. So this is what I am talking about. I am saying that if you have alpha infers beta, it if and only if alpha infers beta, this is the definition. You can just very easily see alpha infers beta if and only if alpha implies beta is a tautology. Is a tautology. This is the definition. Alpha infers beta if and only if alpha implies beta is tautology. So whenever you see this alpha infers beta, you can replace this. You can just directly see that this means alpha implies beta is a tautology. Another example, you can notice that, for example, P or Q, negation Q infers P. Okay, so actually you can very easily see this is also correct. This is also correct. Why? Because this is saying that P or Q, this P or Q is true, Q is false, then definitely we can say P is true, right? Okay, see, Q is false. This means Q is false. This means Q is false, and this means P or Q is true. Okay, so this means Q is false. This means P or Q is true. So then definitely we can say, because Q is false and P or Q is true, then definitely P is true. Okay, so I can say that these two, I can say that these two, they infer P, they infer P. Okay, and you can also check in another way. You can check. I can say that this and Q bar implies P is a tautology. Is a tautology. So what we mean to say? So if you have this, for example, you have some statement S1, you have some statement s2, you have some statement s3, you have some statement s4. Inverse s, what it means, this inverse s if and only if s1 and s2 and s3 and s4 implies s is a tautology, is a tautology. This definition we have already seen, and remember this is called knowledge base. We call this knowledge base. Okay, and this we call conclusion. This is what we call conclusion. So I can say this is the knowledge base. So what is a knowledge base? Knowledge base, what is knowledge base? This is set of premises. For example, here this is the knowledge base p or q. Okay, this is basically the knowledge base here. So what is the knowledge base here? I can say knowledge base is basically p or q and negation q. So this is the knowledge base in this example. In this example, this is the knowledge base. In this example, knowledge base is basically p and q. Okay, so this is the knowledge base. And in this situation, I can say knowledge base is basically s1 and s2 and s3 and s4. Okay, so this is the knowledge base here. So this is the simple idea. So I can say that knowledge base is basically a propositional formula. Okay, so in simple terms, I can say that knowledge base is a basically this is a proposition, or I can say this is a propositional expression. This is basically a propositional expression. Okay, so this is the definition of knowledge base. This is set of premises. So if you have four premises s1, s2, s3, s4, then I can say knowledge base is basically s1 and s2 and s3 and s4. And this is the symbol for inference. I can say that s1, s2, s3, s4, they infer c if and only if s1 and s2 and s3 and s4 implies s is a tautology. This is the definition. So alpha infers beta if and only if alpha implies beta is a tautology. This is the definition of logical inference. We already know from our lectures. Okay, this is just a quick revision. Now let's see this question. So which of the following is possible? The question is asking which of the following is possible. The question is saying the option 1, knowledge base infers s and negation of knowledge base infers s. So let's check whether it is possible or not. So the option A is saying that knowledge base infers s and negation of knowledge base infers s. Is it possible? Let's check whether it is possible or not. So you know knowledge base is nothing but some expression. Knowledge base is basically some expression over some propositional variables. So we don't know what are these propositional variable. I don't know. Okay, so let's assume these are the propositional variable. We don't know what are those propositional variable because we know that knowledge base is some expression. And this is some expression, knowledge base, as we have already seen. For example, in this example you can notice this is the knowledge base. Okay, so knowledge base is basically a propositional expression over some propositional variables. These are the propositional variables we don't know. But now, okay, s is another proposition. Okay, this is some another proposition. Now what we need to check, we need to check, is it correct? Knowledge base infers s and no, negation of knowledge base infers s. Now we have already seen, I told you that whenever you see this alpha infers beta, then you can just replace with alpha implies beta is a tautology. Okay, so if I say that alpha infers beta, this simply means that alpha implies beta is tautology. So I can say that knowledge base infers s. This simply means knowledge base implies s is tautology. It simply means that this is a tautology. This is simply tautology. Okay, and no, okay, this negation of knowledge base implies s. This is also tautology. So we just need to check whether it is possible or not. This is what we need to check. We need to check, is it possible that knowledge base implies s is also tautology and knowledge negation of knowledge base implies s is also tautology. This is what we need to check. Okay, this is what we need to verify whether this and this is possible, means this tautology, is it possible? Now let's check, is it possible? Think about it and tell me, is it possible? It is definitely possible, because remember, for any combination of the propositional variable, we don't know what are the propositional variable here. Okay, so let's assume p, q, r something. Okay, so some propositional variables you have, I don't know what are the propositional variable, but whatever combination, whatever row of truth table you take, whatever combination of truth values you take for the proposition variable, what we want that this should be true and this should be true. Okay, now notice that s can never be false. Here you can very easily see that s can never be false. Why s can never be false? Just think about it. If s is false, Now you can notice what will be knowledge base. See, if s is false for this row, for this combination of truth value, or I can say for this row of truth table, if s is false, then there is a problem. What is the problem? See, if s is false, let's assume knowledge base is false, then in this situation this will be false. In this situation this will be false because knowledge base is false. For this row, for the first row, knowledge base is false and s is false, so definitely knowledge base negation will be true. True implies s is false, so true implies false is false, so this will become false. So I can say that definitely knowledge base can, okay, definitely this situation is not possible. This situation is not possible. Now let's see, is it possible that no, s is false and knowledge base is true? Is it possible? Think about it. Is it possible that s is false, knowledge base is true for any row? For any row in the truth table, is it possible? This is also not possible because in this situation, for this row of the truth table, this will become false. This will become false. So this is also not possible. Okay. What else? No, the only thing, remember s cannot be false. So we can see that s can never be false. If this and this both are possible, then it means s can never be false. Now let's put s true. So if s is true in all the rows, if s is true in all the rows, this is the final thing that is remaining. So I can say, finally I can say that s must be true in all the rows. Now you can very easily see that because s is true, because s is true in all the rows, for every row I can say that s is true. So because s is true, this is true, so this will be tautology. Because s is true, so this will be tautology. So finally I can say that this is tautology, this is tautology. So I can say option A is possible. So the question is asking which of the following is possible. So yes, option A is possible. Next, option B is saying that knowledge base implies S and knowledge base does not imply S. Okay, so let's check this. So the option B is saying that knowledge base infers S. Is it possible that knowledge base infers S and also knowledge base infers S negation? Is it possible? Again, you can very easily check that this is possible because, okay, knowledge base is some proposition. This is some proposition formula over some proposition variables. We don't know what are these proposition variables, so let's assume these are the propositional variable. Okay, and s is another proposition. Now what we need to check, we need to check, is it possible that this and this, okay, means knowledge base infers s. What it means? It means knowledge base implies s is tautology. Okay, this is tautology. And okay, knowledge base implies s dash, this is also tautology. This is the meaning, this is the clear meaning of option B. Now the option B is asking, is it possible that this is also tautology, this is also tautology? Let's check, let's make it possible, let's try to make it possible. Is it possible? Let's check. Okay, now one thing you can observe is that knowledge base can never be true. uh, okay, so one thing, this is what you can observe, that knowledge base can never be true. Why knowledge base can never be true? Assume knowledge base is true for the first row. Assume for any row in the truth table, for any row in the truth table, let's assume knowledge base is true. Now what will be the value of s in this row? In this row of the truth table, what will be the value of s? Let us assume the value of s is true. In this situation there is a problem that this will be false, because remember, knowledge base is true for this row, for this row in the truth table, knowledge base is true, s is true, so definitely this will become false. So definitely this situation is not possible. Okay, I can say this situation is not possible. Let's assume knowledge base is true and s is false. In this situation this will be false. So for this row of the truth table, this will be false. So I can say this will not be tautology. So definitely finally I can say that knowledge base cannot be true. For any row in the truth table, knowledge base can never be true. Okay, so I can say that knowledge base must be false. Knowledge base must be false. Knowledge base must be contradiction. Now tell me, now is there any problem? Now there is no problem, because remember, knowledge, for every row in the truth table, for every row in the truth table, knowledge base is false. So automatically, because this is false, knowledge base itself is false. So I can say that this is also true for every row in the truth table. This is also true for every row in the truth table. So this is also tautology, this is also tautology. So I can say option B is possible. So option B is definitely possible. Similarly, you can try for option C. Option C is saying that knowledge base infers S and knowledge base does not infer S. Is it possible? Knowledge base infers S. So the option C is saying that knowledge base infers S and knowledge base does not infer. Knowledge base does not infer S. This can never happen. You can very easily see this can never happen because this is your knowledge base and S can be anything. Now the question is saying that knowledge base infers S means, okay, means knowledge base implies S is tautology. Knowledge base infers S, it means knowledge base implies S, this is a tautology. Now knowledge base does not infer S, what it means? Okay, so for example, alpha does not infer beta. What's it simply means? This simply means that alpha implies beta is not a tautology. This simply means that it is not a tautology. So it can be contradiction or contingency. So it simply means that this is either contradiction or this is contingency. Okay, so either it is contradiction or it is a contingency. Anyway, so alpha does not infer beta. It simply means that alpha implies beta is not tautology. Not tautology simply means that either contradiction or contingency. Now, this question option C is saying, is it possible that knowledge base infers S? Knowledge base infers S means knowledge base implies S is tautology. So is it possible that this is tautology? And this, okay, and this is not tautology. Is it possible that this is tautology, but this is not tautology? Of course this is not possible, right? Because if this is tautology, then this must be tautology, both are same. Option C is not possible because in the option C what he is saying, he is saying that this is tautology means knowledge base implies S is tautology, and knowledge base implies S is not tautology. Of course this is not possible because if this is tautology, then definitely both are same, these are same, so this must be tautology. So I can say that option C is basically the, okay, option C is not possible, never possible. Okay, because if no, automatically just think about it, if knowledge base infers S, then it cannot happen that knowledge base does not infer S. Similarly, if knowledge base does not infer S, then it cannot happen that knowledge base infers S. So definitely option C is not possible. And what about option D? Knowledge base infers S and knowledge base does not infer negation S. So let's check it out. So option D is saying that knowledge base infers S, okay, and knowledge base does not infer negation S, does not infer negation S. So what this question is saying, this question is saying that you have some knowledge base. Knowledge base is a proposition, this is a propositional expression over some propositional variables which I don't know, which we don't know. Okay, now this is knowledge base, this can be some expression. I told you that knowledge base is basically some propositional formula, and this is another propositional formula S. Now the question is saying, is it possible that knowledge base implies S is tautology? Is it possible that this is also tautology and this is not tautology? Is it possible that this is tautology but this is not tautology? Okay, so the question is asking that is it possible that knowledge base implies S is tautology but knowledge base implies S bar is not tautology? Not tautology simply means that somewhere you have false. Not a tautology simply means that somewhere you have false. Okay, this is the meaning of not a tautology. Not tautology means, so is it possible? Tell me, just think about it. Is it possible? We don't care about other things, we don't care about other things, but tell me, is it possible that knowledge base implies S is tautology but knowledge base implies S bar is not tautology? Not tautology means for some row in the truth table we have false. Okay, so let's see whether it is possible or not. So let's check, can we make it possible? Yes, of course we can make it possible. Okay, so to make it possible here, because this should be false, so definitely S must be true, so S must be true and knowledge base must be true. Okay, so for this row, for this particular row, I can say knowledge base must be true and S must be true. Then definitely you can see this is also true for this row and this is also false for this row. Okay, and for the remaining rows, what you can do, for the remaining rows you can simply make the okay knowledge base false. So definitely what I can say, I can say that it is definitely possible that this is tautology but this is not tautology. Okay, so this is definitely possible, so I can say option D is possible. Option D is basically possible. So here, which of the following is possible? So the answer is option A, B, D. These are possible. So this is the concept of inference. Okay, the concept is very simple. Remember, whenever you say that alpha infers beta, it simply means, okay, you don't have to see, don't get afraid of this. This is not a, like I can say, this is not something scary. This is very simple. Alpha infers beta, it simply means that alpha implies beta is a tautology. This is the simple meaning. Alpha infers beta, it simply means that alpha implies beta is a tautology. Also, alpha does not infer beta. What it means? Alpha does not infer beta. What it simply means? It simply means that alpha implies beta is not a tautology. Not a tautology means contradiction or contingency. So this is not a tautology. So just apply this definition, nothing else. Okay, so this is the concept of, and what is knowledge base I have already explained. You can notice here in these examples I have already explained what is a knowledge base. Okay, so knowledge base is basically a set of premises. Okay, so I can say if knowledge base is set of premises like s1 s2 s3, these are the statements in the knowledge base, then I can say that knowledge base is basically s1 and s2 and so on sn. Okay, so this is the knowledge base. So knowledge base is definitely a propositional expression, or I can say proposition formula. And so this is the question, and the question is asking which of the following is possible. So this is a simple question, but this is analytical one. Okay, this is question number 5. This is a basically a popular puzzle. Now, when asked for the ages of her three children, Mrs. Baker says, okay, so this is the statement. Mrs. Baker says, Alice is her youngest child if Bill is not her youngest child, and that Alice is not her youngest child if Carl is not her youngest child. Okay, note that only one of the three children can be her youngest child. Which of the following is correct? So basically, the question is asking who is her youngest child. Now, okay, so you can pose the question and you can think about it how to solve this question. The question is very simple. Remember, in this type of puzzle related questions, you just have to think, okay, you just have to write it in the proposition logic format. Okay, in the logical format you write, in the mathematical format you write. So what is the statement that this Mrs. Baker has given? This Mrs. Baker is saying that, okay, so this is the statement Mrs. Baker is saying that Alice is her. Okay, so first of all, let me assume that Alice is her youngest child. Let me assume that this is A. Let me call it B. Let me call it C. Okay, so remember, I'm basically creating three variables, three proposition variable I am creating. A means Alice is youngest child. B means Billy is youngest child. C means Carl is youngest child. Okay, so I'm creating three propositional variable. This is what I am doing. Okay, now, once I have created these three proposition variable, then what is the statement of Mrs. Baker? Mrs. Baker is saying that Alice is her youngest child, which means A, if Bill is not her youngest child. So what it means? It simply means that B bar implies A. Okay, so A if B bar, I can say A if B bar. It simply means B bar implies A. And okay, so this is the statement, and okay, Alice is not her youngest child if Carl is not her youngest child. It simply means that negation C implies negation A. So this is the question. Okay, so the question is very simple. So this is the statement which Mrs. Baker is saying. Mrs. Baker has basically said this statement that B bar implies A, and C bar implies A bar. Okay, so this is the statement which Mrs. Baker is saying. Now we have to find out who is the youngest child. From this statement, we have to find out who is the youngest child. Okay, so now you can notice this statement also. Note that one, okay, only one, okay, can be the youngest child. Of course, only one can be the youngest child. So basically, I can say that A, B, C. Remember, A means Alice is the youngest child. B means Bill is the youngest child. C means Carl is the youngest child. I can say exactly one of them true. This is the point. Exactly one of them is true. Exactly one of them is true, I can say. Remember, ABC, these are propositional variable. A is the propositional variable for this statement that Alice is youngest child. C is the proposition variable for this statement Carl is youngest child. Similarly, B is propositional variable for this statement that B is youngest child. So okay, so you can clearly see that the question is saying that exactly one of them is youngest child. So I can say that exactly one of them is true. A, B, C, exactly one of them true. This we know because of course only one can be the youngest child. One of them can be the youngest child. Okay, so this is already given in the question that exactly one of them is true. So these are the possibility. Either this is the possibility. It means Alice is the youngest child. and Bill comma Carl, they are not yet, they are not the youngest child, or Bill is the youngest child, or C is Carl is the youngest child. Only these are the three possibilities possible, right? Only three possibilities are this, nothing else. Okay, so because the question is saying that only one can be the youngest child, so either Alice or this Bill or Carl. Okay, so these are the three possibilities, nothing else is possible. Now let's see for which possibility Mrs. Baker's statement will be true. For which of these possibility Mrs. Baker's statement, this is Mrs. Baker's statement, that this, okay, and this is Mrs. Baker's statement. Now let's see for which of these following situations, whether this or this or this, for which of them Mrs. Baker's statement will be true. So for this first situation where A is true, B is false, C is false, okay, then in this situation, because C is false, so this will become true. Okay, A is true, so this will become false. True implies false will become false, and false and anything is false, so basically here it will become false. So Mrs. Baker's statement, this is Mrs. Baker's statement, this will become false for this situation. It means Alice is definitely not the youngest child, so I can say this is definitely not possible. Now let's see option B. Okay, so option B means Bill is the youngest child. Now let's see for this situation when Bill is the youngest child, can I say Mrs. Baker's statement will be true? So because in this situation you can notice A comma C are false, B is true. Okay, so let's see what is this value. So B bar, that will be false. False implies anything is true, so this will be true. This will be true. Okay, and C bar, that is true, implies C bar, that is true, implies A bar, that is true. Okay, so true implies true, that is also true, so true and true, that will be true. Now in for the final row, okay, so you can notice for the final row when Carl is the youngest child, so because C is true, so this will become false. False implies anything that is true, so this will be true. Now B is false, so this will be true, and A is false, so true implies false is false. False and true is basically false, so I can say this will be false. So what is the answer? You can clearly see that for only this situation, only for this situation, Mrs. Baker's statement will be true, so I can say Bill is the youngest child. Okay, so the answer will be Bill is the youngest child. So this type of puzzle, this type of questions, already this type of questions have can come in the gate exam. Okay, you can find there are three or four questions which are based on puzzles in the gate exam. So this type of questions are very you can notice, okay, very important, and you can very easily you can solve them. So always what you do, so the question is given to you, just convert this into logical format. Okay, so what we have done, this is the statement of Mrs. Baker, we have converted into logical format. This is the logical format, so I can say that this is the statement of Mrs. Baker. Now the question is saying that one of them must be the youngest child, so I can say A, B, C, Alice, Bill, Carl, exactly one of them is a youngest child, so I can say exactly one of them is true. So finally either this is possible or this is possible or this is possible, but we can see that only for this situation when B is the youngest child, only for this situation Mrs. Baker's statement will be true. Okay, in all other situation, if you assume that Alice is the youngest child, or if you assume that Carl is the youngest child, in both these situations Mrs. Baker's statement will be false, so I can say answer will be, okay, Bill is her youngest child. Okay, let's solve this question number 6. This is another puzzle, and this question is saying that a boy and a girl are talking. One of them has black hair and another has white hair. We don't know, like basically there is a boy, there is a girl. One of them has black hair, another has white hair. We don't know who has black hair, who has white hair. Now the question is saying, I am a boy, said the child with black hair. I am a girl, said the child with white hair. At least one of them is lying. This is given to us. This is given to us that at least one of them is lying. Now the question is asking who is lying. So remember, this type of question also you can solve very easily because only two cases are possible here. Okay, remember there is a boy and there is a girl. So I can say there is a boy, okay, there is a boy and there is a girl. And now we don't know who has black hair, who has white hair. So we can create cases. I can create case 1, okay, and I can create case 2. So case, either case 1 is possible or case 2 is possible. So in the case 1 I am assuming that boy has black hair, so let's assume boy has black hair, okay, and let's assume girl has white hair. Because remember This is already given to you that there is a boy, there is a girl. Okay, this is already given. Also it is given that one of them has black hair, one of them has white hair. Now we don't know who has black hair, who has white hair. We don't know whether boy has black hair or white hair. So we can create two cases. I can say that in the first case I am saying that boy has black hair. In the second case I am saying that okay, boy has white hair. Okay, and similarly this girl, in the second case girl has a black hair. Okay, now let's see. Now let's see. And the question is saying that at least one of them is lying. Okay, so let's see, at least one of them is lying. Now in this situation, okay, in this situation, remember, we are assuming that okay, either this case is possible or this case is possible. Okay, only one of them is possible. Now in this case, boy has black hair, but the boy is saying, okay, the child with black hair is saying I am boy. Remember, who has the black hair in this case? In this case, boy has the black hair, and the child with black hair is saying that I am a boy. So basically boy is saying that I am a boy. Boy is saying that I am boy. I am boy. I am a boy. Okay, then definitely there is nothing. Okay, and you can notice the the child with white hair is saying that I am a girl. Child with white hair means girl, so girl is saying that I am a girl. So here there is no false, right? Both are okay. So basically no one is lying here. Here no one is lying. In this case you can very easily see that no one is lying. In this case you can see that no one is lying, but the question is saying someone is lying. At least one of them is lying. So this case is not possible. Remember, in the question, in the beginning of the question, we don't know whether the boy has black hair or boy has white hair. We don't know. So we are creating two cases. Now we are finding that in the case one, no one is lying, but the question is saying at least one of them is lying. Okay, so definitely case one is not possible. So I can say that definitely case one is not possible. Okay, so case 2 is possible. Okay, so because if case 1 is not possible, then definitely case 2 is possible. Now in the case 2, okay, in the case 2, boy has white hair. Boy has white hair, and the child with white hair is saying I am a girl. Boy has white hair, so boy is saying that I am a girl. Okay, so definitely boy is lying. And child with black hair is saying that I am a boy. Child with black hair, child with black hair is saying I am a boy. So girl is saying I am a boy. Boy is saying I am a girl. So definitely I can say both are lying. So I can say both are lying because the question is saying at least one of them is lying. Okay, so finally I can say that both of them are lying. So answer will be option C. So this is another very simple question because only two possibilities are there. We don't know who has black hair, who has white hair. So we can create two cases. In the case one, no one is lying, but the question is saying that at least one of them is lying. So we can say case 2 is possible. In case 2 you can see that both are lying, so I can say that answer is both are lying. Okay, this is a question from arguments in propositional logic. Consider the following two arguments. Logical arguments are given to you. Argument 1 is saying that carriers or Myrna fails to show. If carriers, then he does not break the record. Okay, Myrna fails to show. Therefore, carry does break the record. So first, this is the argument one. First, you convert into argument form. So this is the first step. Okay, always what you do, you convert. This is the English. This is the English format. So you convert this English format into propositional logic format, into mathematical format. So first, what you do for this argument one, you create the argument form. This is what you do. You create argument form. So what will be the argument form of this argument? So for this argument one, I can say carriers. Let me call it K. Let me call it E. Carriers. Okay. Let me call it E. Or okay, fails to show. Or I can say okay, fails to show means doesn't show. Fails to show means doesn't show. Okay. So I can say that fails to show means doesn't show. Okay, if carriers, he does not break the record. If carriers, so I can say if carriers, then he does not break the record. He does not break the record means does not break the record. Now Myrna or whatever it is, Myrna whatever, okay, fails to show means fails to show. Therefore carry does break the record. Therefore B. Okay, so first of all what you do, this is the given argument, you convert this argument into argument form. This is called argument form. You can call it, this is called argument form. Now check whether this is a valid argument or not. And the best method, I told you in the class, we have already seen, for any argument question the best method is you create or you make the conclusion false and then you try to make all the premises true. After making the conclusion false, if you can make all the premises true, then it means it is not a valid argument. Okay, so because what you can do, see, first what you do, first you make it false, first you make it false, means B is false. You make it first, you make the conclusion false, conclusion means B, so first you make it false. Now what you do, you try to make all of them true, you try to make all of them true. So let's try to make it true. How can I make it true? To make it true, S must be false. Now let's try to make it true. Now let's try to make it true. Remember, B is already false, so this is a true. B is already false, so this is true. Because B is false, so B bar is true. Anything implies true, that is true. So here, okay, anything here, E can be anything. I can say that here E can be anything. I can say that here E can be anything, because remember, anything implies true, that is basically true. So E can be anything. Now S is already false, so this is a true. S is already false, so this is true. True, okay, true or anything, that is actually true. So here again I can say that E can be anything. E can be anything. So okay, what you can see here, after making B false, after making the conclusion false, this is the conclusion. After making the conclusion false, you can easily make the, you can easily make all the premises true. After making the conclusion false, you can easily make all the premises true. This premise is true, this premise is true, this premise is true. All the premises are true after making the conclusion false. What it means? It means that all the premises are true, still the conclusion is false. It means this is basically invalid argument. This is simply invalid argument, because after making the conclusion false, you have created each and every premises true. Okay, and that means it is invalid argument. Let's see argument 2. In the argument 2, again you convert this argument 2 into the logical format, or I can say argument form. So for the argument 2, you write the argument form. So what will be the argument form of this argument 2? What that will be? So that will be, if Tasa leaves, then Carol moves on. Okay, so basically, if Tasa leaves, then Carol moves on. If Carol moves in, then Sam is not happy. If Carol moves in, then Sam is not happy. If Sam is not happy, then Joff laughs. If Sam is not happy, then Josh laughs. Okay. Sam is happy. Sam is happy. Hence, Tasa does not leave. Hence, Tasa does not leave. Okay, so this is the argument form. For the second argument, this is the argument form. Now let's check whether it is valid argument or not. I told you the best method, that first you make the conclusion false. So first you make this conclusion false. To make the conclusion false, T must be true. So you can very easily see this T. This T basically, this must be true. Okay. Remember, this T must be true. Okay, this T means Tasa. I can call it, this T is basically Tasa. Okay, means Tasa leaves. Okay, this means Tasa leaves. This is not T means true. Remember. So what I'm saying that first you make this conclusion false. So it means T must be to make this conclusion false. This T must be true. Okay. Now what we will do? We will try to make each and every conclusion true. Each and every premise is true. So let's try to do that. Okay, what we will do, we will try to make each and every premise true. So can you make it true? Yes, definitely I can make it true. So S should be true. Okay, now can you make it true? Can you make it true? Remember, S is already true, so this is already false. False implies anything is true, so J can be anything. J can be anything. We don't care about J can be anything. Okay, so you have created these two premises, you have created true. Now S is already true, so this will be false. So this will be false. Now to make this premise true, this second premise, if you want to make it true, if you want to make it true, then definitely C must be false, because already S is true, so S bar will be false. So C implies false. So if you want to make it true, then C must be false. Now C is already false. Okay, and Tasa, this is basically true. So I can say that this I cannot true. I can say that this cannot be true. This premise cannot be true. So you can see that after making the conclusion false, whatever you do, you can never make all the premises true. This is not possible that all the premises are true, but still the conclusion is false. So I can say that this is a valid argument. So this is simply a valid argument. The answer is only argument 2 is valid. So which of the following is true? This is asking. So argument 2 is valid. Only argument 2 is valid. So this is the answer. Let's solve this question number 8. This is another question based on arguments. So two arguments are given. First, what you do, I told you that these are English arguments, these are in the English format, these are in the English language. First you convert them into argument form, logical format. The attack will succeed only if enemy is taken by surprise or position is weakly defended. Okay, so this is the attack will succeed. The question is saying attack will succeed only if, only if the attack will succeed only if, and we already know, so this I we have already seen that p only if q, what this means, this simply p only if q, what this means p implies q. We have already seen in the lecture, I told you why it happens. Okay, the reason I told you, the proof I told you basically. Okay, p only if q, it means p implies q. The attack will succeed implies only if, that implies I can say enemy is taken by surprise or position is weakly defended. Okay, so attack will succeed if enemy is caught by surprise or weakly defended. Okay, or weakly defended. Now, the enemy is not taken by surprise unless he is overconfident. And okay, what it unless means, this we have already seen. Unless simply means if not. Okay, unless simply means if not. For example, if I say a p unless q, what it means, it simply means p if not q. Okay, p if not q. So I can simply say that if not q then p, p if not q, p if not q. Okay, so I can say if not q then p, if not q then p. What it simply means, it simply means that negation q implies p. So this is the statement. So you can notice that the enemy will not be taken by surprise. Okay, so unless, this is the meaning of unless. Actually you can also see very easily that unless simply means if not, or it simply means or. So if I say that p unless q, you can write it, you can write it negation q implies p, like this we have seen. Okay, you can simplify this as q or p. So that's the reason I can say p unless q, that means p or q. So the enemy will not be taken by surprise. Okay, or unless he is overconfident. Okay, the enemy will not be overconfident if position is weakly defended. If position is weakly defended, the enemy will not be overconfident. Therefore, attack will not succeed. Therefore, what will happen? So I can say attack will not succeed. Okay, so this is the argument. This is the argument form of the second argument. Now let's see whether it is valid or not. To check the validity of any argument, the best method is to make the conclusion false. To make the conclusion false, what you do? So first what you do, this just make it false. Just make it false. So here A will be true. Okay, so A is true. Now what you do, you try to make all the premises true. Let's see how can I make this all the premises. So let's, can I make this true? All the premises I will try to make them true. So A is already true, you can notice, because A is already true. So okay, to how to make this premise true? A is already true, then definitely this should be true. Then definitely this should be true. S or W, that should be true. So I can say that S or W, this should be true. Okay. Next, how to make this true? How to make this? How to make this true? Let's see how to make this true. To make this true, you can notice at least one of them must be true, and we also need to make this true. Okay. So here you can notice that S or W must be true. Okay, now can we make all of them true? This is the point. So let me check. So let me make W false. If I make W false, then this will become false. Then false implies anything is true. So if I make W false, then what I can do, I can make this true. I can make this true. If I make W false, if I make W false, then definitely S must be true. Definitely S must be true. Okay. So because S is true, so this will be false. So O can be made true. So if I make O true, okay, so this is the answer. You can very easily see what I can say. I can say that after making conclusion false, I can make all the premises true. All you have to do, make W false or true. Make W false or true as true. Okay, so just to do this. If we do all of them, then we can easily see that all the premises are true. Okay, all the premises are true, but uh, so all the premises are true but conclusion is false, so I can say that this argument is also invalid. So this is an invalid argument. So let's see this argument 1. In this argument 1 we are saying that If it does not rain or it is not foggy, then selling race will be held and life saving demonstration will go on. So first you write this argument 1 in argument form. Okay, so the question is saying, if it does not rain, if it does not rain, or the fog, or it is not foggy, it is not foggy. Okay, so if it does not rain and it is not foggy, then we can say that the sailing race will be held and life saving demonstrations will be there. Okay, next, if the sailing race is held, if the sailing race is held, then the trophy will be awarded. Then I can say trophy will be awarded, trophy. Okay, so then trophy will be awarded. And next, the trophy was not awarded, hence it ran. Okay, the trophy was awarded, so this was not awarded, hence what we can say, it ran. It ran means r. Okay, so let's see whether this is a valid argument or not. The best method is make the conclusion false. So how can we make the conclusion false? Definitely r must be false. Now we will try to make all the premises true. How to make this true? So to make this true, I can say that trophy must be false. Okay, if I want to make this true, then I can simply say that trophy must be false, because if trophy is false, then this premise will be true. Now trophy is already false, so how can I make this true? Because trophy is already false, so automatically s must be false. Now s is already false, so this will be false. Now already remember, as r is already false, so this will be true. Okay, now this is true, true or anything is true, so this whole thing is true. True implies f is false, so I can say that this cannot be true. I can say this cannot be true. So what I can say, I can say that after making the conclusion false, whatever you do, whatever you want, you can do. After making the conclusion false, whatever you do, you cannot make all the premises true. So this is a valid argument. Means, if I can also say, I can also, in other words, I can say that if all the premises are true, then conclusion cannot be false. Or I can say, if conclusion is false, then you cannot make all the premises true. You, whatever you do, you can never make all the premises true. So for example, here you can notice we cannot make all the premises true. So this is valid argument. So for this question, I can say option A. Okay, only argument 1 is valid. Okay. Now solve this question. This is question 9. This is another puzzle and this is very interesting. So there are 5 people, A, B, C, D, E, which are they are in a compartment in the train. A, C, E are men, B, D are women, and the train passes through a tunnel. And when it comes out, basically it is found that E is murdered. An inquiry is held. A, B, C, D make the following statements. So these are the everyone is making two statements. A is making two statements. I am innocent and this. Okay, B is saying I'm innocent this, C is saying I'm innocent this, okay, and D is saying I'm innocent and this. So okay, total 8 statements are there. You can notice A, B, C, D, all of them are making two statements. So total we have 8 statements, and the question is saying that 4 are true, 4 are false. Now who is the murderer? So this is a very nice question. Now just think about it. Okay, this is a very nice puzzle. This is a logical puzzle, you can very easily see. This is a puzzle from propositional logic, you can think about it. Okay, so now what is the answer? The answer is very simple. See, everyone is making two statements. Okay, so this A is making two statements, A1 comma A2, and I can say that B is also making two statements, B1 comma B2, and similarly C is making two statements, C1 comma C2, and D is making two statements, D1 comma D2. And you can notice that these, look at these statements, everyone is saying that I'm innocent. Everyone is saying A, B, C, D, all of them are saying I am innocent, I am innocent, I am innocent, I am innocent. Okay, so you can notice one of them is murderer. Okay, if you notice that 4 are true, 4 are false, means okay, out of all these 4 statements are true, 4 statements are false, but you can notice all of them are basically I am innocent, I am innocent, I am innocent, I am innocent. So here I can say that 3 must be true, right? Because one of them is murderer. A, B, C, D, one of them has done the murder. Okay, now I can definitely say, if for example, if A has murdered, then I can say that these are true. Then I can say these are true, because they are saying we are innocent. If A is the murderer, if A is the killer, then I can say B, C, D, these statements are true. Similarly, so whoever is the killer, I don't know who is the killer, but whoever is the killer, I can say 3 of these statements are true. So this is what I can say. I can say that 3 of A1 comma B1 3 of a1 comma b1 comma c1 comma d1. Three of these statements are true. Three of these statements are true. Okay, and you can notice, just focus on this statement and this statement, means focus on these two statements. Okay, so this statement is saying that A is saying that B was talking to E when train was passing through the tunnel. Okay, so this statement is saying B was talking to E, and this statement is saying that B is saying that I was not talking to E. So here he is saying that B is talking to E, and B is saying that I am not talking to E. So what it means? It means one of them is true, right? Yes or no? Okay, one of them is true, because okay, we don't know who is the killer, but we know that one of them is true. Basically a2 is a complement of b2, I can say. A2 is statement a2 is a complement of b2, then definitely one of them must be true. So I can say one of a2 comma b2 must be true. Okay, so you can notice very easily, you can notice three of these is true and one of these is true. So definitely I can say that the okay, four of these is true. So what I can say, finally this is the conclusion I can say. So four statements are true in these. Among these, four statements are true. This is what we can say. Among these four statements are definitely true, because you can notice three of them is true, one of them is true. So I can say among these statements, four of them are true. And the question is saying four are true, four are false. It automatically means that we can guarantee these are false. We can guarantee these are false. This is what we can guarantee. This is what we can guarantee, that these are false. This we can guarantee. So c2 and d2 they are false. Okay, c2 and d2 they are false. And so this is false. D committed the murder. This is false. It means D did not commit the murder. Remember, this is false. I can say this is false. What it means? It means D did not commit the murder. So D is not a murderer. D is not a murderer. Okay, D is not a killer. And this is false. And this is a false. This is false. What it means? It means that one of the men committed murder. So this is false. Means man did not commit the murder. Man did not commit the murder. It means women committed the murder. Okay, and D did not commit the murder. So I can say B committed the murder. Okay, so who is the killer? So answer is option B. So the okay, this question is very simple. You can very easily see that everyone is making two statements. Okay, A is making two statements, A1 A2. B is making two statements, B1 B2. But here you can notice these all statements. Notice these statements: I am innocent, I am innocent. So definitely one of them is killer. So definitely the other three people are saying the truth. Okay, one of them is killer, then definitely the other three people are saying the truth. So I can say among these three statements are true. And you can notice these two statements are complement of each other. A2 B2, these are complement of each other. So one of them is true. So I can say that in these statements I can say that four of them are true. So definitely I can guarantee that these two are false. C2 D2, these are false. So C2 D2 is false. It means D did not commit the murder, and okay, man did not commit the murder. So I can say that B is the murderer. So this is a very simple question. Let's see another question. This is question number 10. Alpha beta are propositional formula, then which of the following is or are false? Okay, so the question is very simple. Alpha comma beta, these are propositional expression, and then which of them is false? The option A is saying that, option A, what this is saying? This is saying that if negation alpha or beta is valid, then alpha infers beta. First of all, actually, you can solve this question very easily, because you already know that negation alpha or beta, this is same as alpha implies beta. Okay, because alpha implies beta. If you have alpha implies beta, you can also write it negation alpha or beta. Okay, so I can say this is actually nothing but alpha implies beta. Now the question you can very easily read. So if alpha implies beta is valid, valid means tautology. In the propositional logic, valid simply means tautology. In the propositional logic, this we have already seen. In propositional logic, this happens that valid means tautology. So okay, this option A is saying that if option A is basically saying that if alpha implies beta is tautology, if this is tautology, then alpha infers beta. This is correct. This is the definition of inference, right? This is the definition of inference we have seen. Alpha infers beta. It automatically means that alpha implies beta is tautology. Okay, this we have already seen. alpha inverse beta if and only if alpha implies beta is a tautology. This is the definition of this symbol. This is the definition of this symbol. This is the inference symbol. Okay, so I can say this statement is definitely true. Okay, the question is asking false. So I can say this statement is basically true. Okay, what is option B? Option B is saying, okay, if alpha implies beta is valid, then what can you say about negation alpha inverse beta? So the option B is saying that alpha implies beta is valid. This is a tautology. This is already given to you that this is a tautology. Okay, so alpha is some proposition formula, beta is some propositional formula. Okay, we don't know. These are the proposition formula over some propositional variable. We don't know what are the variables. Okay, so alpha comma beta are propositional expressions over some propositional variables. These are the propositional variables, or I can say these are the atomic propositions. Okay, now the question is saying that alpha implies beta is a tautology. This alpha implies beta. This is basically tautology. This is what question is saying. Okay, now the question is saying if alpha implies beta is tautology, then can I say negation alpha inverse beta? If alpha implies beta is tautology, then what can you say about negation alpha implies beta? Can I say this is also tautology? Okay, the question is asking, this is given to you, and the question is asking negation alpha inverse beta. Is it true? Is it true? Okay, what it means? It means negation alpha implies beta is tautology. So can I say this is tautology? Can I say? Okay, let's check. Can I say this is tautology? Can I say this is tautology? The answer is no. You cannot say that this is tautology. See, if alpha implies beta is tautology, then you cannot guarantee that this is tautology. Because what you can do, for example, in this situation, you okay, just look at this situation. If I do true true, okay, if I take like this, if I take like this, let's assume alpha is tautology, let's assume beta is tautology. Now you can notice alpha implies beta is definitely tautology, but you can notice that this is not tautology, because here alpha is true, beta is true. Okay, so in this situation, okay, so actually what we can do, so let's do, okay, in this situation actually this will be tautology. So let's do something else. So let me make it false. Okay, so okay, we can do like this. Okay, just think about it. What we can do, we can do like this: false, 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 true, 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 true. Now what you can see, now in this situation alpha implies beta will be tautology, this will be tautology, but in this situation this alpha is false, so alpha bar will be true. Okay, so alpha bar will be true. Okay, so just make this also false. Now you can notice, so anyway this is definitely true. Okay, false implies false is true, so this is definitely tautology, but in this situation you can notice this will not be tautology. So what I want to say is option B is definitely wrong. This is definitely wrong. The question is asking which is false. Remember what we are saying, we are saying that if alpha implies beta is tautology, it does not mean that alpha dash implies beta will also be tautology. It does not mean. Okay, so option B is definitely false. And what about similarly option C? Option C is also false. You can very easily see that option C is also false. Option C is saying that alpha implies beta is tautology, that is fine. Alpha implies beta is tautology. If alpha implies beta is tautology, then what can you say about alpha implies beta bar? This is the question. Alpha implies beta bar. What can you say about this? Can I guarantee that this also will be tautology? And the answer is no. Okay. Again, what you can do, you can just create this situation. Okay, just create this situation you create. Now in this situation you can notice this will definitely be a tautology, but this will not be a tautology. You can very easily see this will not be a tautology. So I can say this option C is definitely false. Next, again, next, alpha implies beta is tautology. Then can I say that negation beta will imply will infer alpha? Okay, so actually you can notice the question is saying that if alpha implies beta is tautology, if alpha implies beta is tautology, the option D, what the option D is saying? Option D is saying that if alpha implies beta is tautology, then what can you say about negation beta inverse negation alpha? Can I say this will be true? Basically, what this means, this simply means that negation beta implies negation alpha is tautology. Is it tautology? Okay, so can I say if alpha implies beta is tautology, then can I say that negation beta implies negation alpha is also tautology? Yes, definitely, because this is contrapositive of this. Actually both are same. This and this both are basically equivalent, because you know that for alpha implies beta, what is the contrapositive? The contrapositive, what is the contrapositive? That will be negation beta implies negation alpha. So I can say alpha implies beta is tautology, then automatically it means negation beta implies negation alpha is also tautology, because they are contrapositive of each other. So I can say this is a true, option D is actually true. And the question is asking which is false, so answer will be option B comma answer will be option B comma C. Okay, let's see next question. This is next question, question number 11. Okay, alpha beta are proposition formula. Which of the following assertions are true? Okay, so there are four statements are given to you. Now let's see which of them are true. Option A is saying alpha is valid. Valid in the propositional logic. Remember, in the propositional logic, valid means tautology. Alpha is valid if and only if true inverse alpha. Okay, so this option A is saying that alpha is valid if and only if true inverse alpha. First of all, okay, don't remember, this is not scary, just convert this. What it simply means, it simply means that true implies alpha is a tautology, is a tautology. It simply means this. So alpha is valid if and only if true inverse alpha. True inverse alpha simply means that true implies alpha is tautology. And what is this true inverse alpha? This means true dash or alpha, and this simply means alpha. So I can say that alpha is tautology. So the statement you can, okay, what you have done now, this statement you have changed. So now the statement is alpha is tautology if and only if alpha is tautology. Because remember, true inverse alpha, what it simply means, it simply means alpha is tautology. It simply means alpha is a tautology. Okay, because true inverse alpha, I can write it like this. True implies alpha is tautology. True implies alpha, it simply means implies alpha is tautology. It simply means true implies alpha is a tautology. But you can notice that true implies alpha, this true implies alpha, this is same as alpha. This true implies alpha is same as alpha. So I can say that alpha is tautology. So alpha is valid if and only if alpha is tautology. This is correct. So okay, the question is asking true. So this is correct. Because in the propositional logic, valid is same as tautology. This we have already seen many times. We have already seen that in propositional logic, this valid, if a formula is valid, it simply means that it is a tautology. Valid simply means that it is always true. Okay, and option B, for any alpha false inverse alpha. Option B is saying that for any alpha, whatever alpha you take, false always inverse alpha. Is it true? Whatever alpha you take, can I say false always inverse alpha? Again, what it means, first you understand what it means. Remember, the question is very simple, but what it means, it means false implies alpha is a tautology. It simply means false implies alpha is tautology. So can I say for any alpha, for any alpha, can I say that alpha implies false implies alpha is tautology? Can I say? Yes, definitely, because this is true. False implies anything. False implies anything. This is equivalent to true. So I can say this is definitely true. This is equivalent to true. So I can say yes, for any alpha, I can say that false inverse alpha. Or I can say for any alpha, I can say false implies alpha is a tautology. Okay, so this is a true. So option B is also true. What about option C? Alpha inverse beta if and only if the sentence alpha implies beta is valid. This is the definition, correct? So this is actually the definition of inference. Alpha inverse beta if and only if alpha implies beta is a tautology. This is the definition of inference. Next, alpha is equivalent to beta if and only if the sentence alpha by implication beta is valid. This is also definition of equivalence. This is the definition of equivalence. We have already seen that alpha is equivalent to beta. It's okay, if and only if. When can I say that alpha is equivalent to beta? If and only if alpha by implication beta is a tautology or valid. So this is the definition of equivalence. Similarly, alpha inverse beta if and only if alpha implies beta is tautology. Tautology means valid. So actually these are the definitions. This is the definition of equivalence. This is the definition of equivalence, and this is the definition of inference. So these are actually the definitions. So I can say Here for this question answer will be option A, B, C, D. This is another MSQ question. All the options are correct. Okay, let's see, this is question number 12. Okay, this is another very simple question, you can just check it out. Okay, so see, many students they just they find this scary. Like, okay, like for example, if I write x inverse y, remember what it simply means. You can simply say that this simply means that x implies y is a tautology. That's it. This is the meaning of it. Okay, so you don't have to find it scary. Okay, so this simply means that x implies y is tautology. It simply means that x infers y. X can infer y. This is the symbol of inference. This symbol is the infer. This is the inference symbol. Okay, so now you can notice question number. This is the question number 12. Alpha beta are proposition formula. Which of them is true? The question is asking for true. Option A. Alpha inverse beta if and only if the sentence alpha and negation beta is unsatisfiable. See, we already know that alpha inverse beta if and only if alpha implies beta is a tautology. Is a tautology. Okay, if this is tautology, now you can notice if this is tautology and this is same as, remember, this is same as negation alpha or beta. So I can say that alpha inverse beta if and only if negation alpha or beta is tautology. Okay, now if this is tautology, if negation beta, if negation alpha or beta, if this is tautology, if this is tautology, then what can you say about its negation? Then what can you say about its negation? What can we say about the negation of it? Okay, if this is tautology, if this alpha dash or beta, if this is tautology, then what can I say about negation of it? Negation of it will be unsatisfiable, and negation of it will be unsatisfiable. This means unsatisfiable. Okay, so this is what we are saying. We are saying that alpha inverse beta if and only if this is tautology. So I can also say that alpha inverse beta if and only if, okay, negation alpha or beta bar is unsatisfiable. Unsatisfiable. Both are same, because remember, this is unsatisfiable automatically means that this is tautology. Okay, so this is what we are saying. If this is tautology, then definitely this will be unsatisfiable. So I can say that alpha inverse beta if and only if this is a tautology, this is unsatisfiable. And what is this statement? This statement is basically alpha and beta bar. So I can say alpha inverse beta if and only if this is unsatisfiable. Alpha and beta bar is unsatisfiable. So this option A is definitely true. What about option B? Alpha, if alpha inverse gamma or beta inverse gamma or both, then alpha and beta inverse gamma. Okay, so let's check whether this is correct or not. Now this option B is saying that if alpha inverse gamma or beta inverse gamma or both, okay, then alpha and beta inverse gamma, then alpha and beta that inverse gamma. So let's check whether this is true or not. So the question is saying that alpha inverse gamma, what it means, it means that alpha implies beta, alpha implies gamma is basically tautology. Okay, so this is basically tautology. Alpha inverse gamma, it simply means that this is tautology. Beta inverse or beta inverse gamma, so either this inverse gamma or beta inverse gamma, either this inverse gamma or beta inverse gamma, so at least one of them inverse. Okay, so let's assume alpha inverse gamma, let's assume. Okay, we don't know about beta inverse gamma or not, because the question is saying if alpha inverse gamma or beta inverse gamma or both. Okay, so let's assume that alpha inverse gamma, then can I say that alpha and beta implies gamma is tautology? Okay, can I guarantee that this will be tautology? Let's check whether we can guarantee or not. Okay, so already you can notice that okay, let's check whether we can guarantee or not. Let's check. So you can notice that can we guarantee that this will be tautology? This is the question, can we guarantee? So let's try to make it false. What we will do, let's try to make it false. Okay, let me try to make it false. So let me make it false. If I can make it false, then option B is a false. Okay, so let me try to make it false. So how to make it false? This is the implication statement. How to make it false? So I have to make this false. I have to make this gamma false. Correct? I definitely have to make this gamma false. If I want to make it false, then I have to make the gamma false, and I have to make this true. Alpha and beta I have to make true. So alpha must be true and beta must be true. Now there is a problem. What is the problem? The problem is that alpha implies gamma is not true. Now this is the problem. So can you see the problem? Okay, the problem is very simple. What I'm saying, option B is given to you. Option B is saying that if alpha inverse gamma or beta inverse gamma or both, then alpha and beta inverse gamma. Now I'm checking whether if this is tautology. Let's assume that alpha inverse gamma is true. Let's assume that alpha implies gamma is tautology. Then I want to check whether this will be tautology or not. Then what I will do, let me make it false. If I can make it false, then it is not tautology. If I can make it false, then option B will be false. So let's see whether I can make it false or not. Okay, so to make it false, what I have to do, I have to make gamma false, alpha comma beta true. But there is a problem. If I do this, then you can very easily see, if I do this, then what will happen? If I do this, then what will happen? This will be false and also this will be false. So if I do this, if I make this false, then you can notice that alpha implies gamma is also not tautology, beta implies gamma is also not tautology. So definitely I can say that there is a problem. Okay, so I can say option B is actually true. Okay, option B is true, because what I cannot do, after making it true, I cannot make it false. Okay, I cannot make it false. After making it true, I cannot make this a false. So this is the idea. Let's see option C. Option C is saying that if alpha and beta implies gamma. Okay, option C is saying that if alpha and beta inverse gamma, then alpha inverse gamma or beta inverse gamma. So basically this is the converse of option B. If alpha beta inverse gamma, then alpha inverse gamma or beta inverse gamma. Is it true? Let's check. Okay, again what I will do, so this is already given to you alpha. Okay, again what I will do, I will try to make this a false. I will try to make this a false. Okay, so already it is given that alpha beta implies gamma. This is already tautology. This is already given to you that this is a tautology. Now what I will try to do, okay, this is saying that then alpha implies gamma or beta implies gamma. Okay, so this is tautology. Either this is tautology or this is tautology. Now can I make it, like, what I will do, I will try to make this false. I will also try to make this false. Can I do that? Let me check. Okay, let me check, can I do that? Okay, so what I will do, I will try to make them false. So let me do that. So what I will do, so you can very easily notice alpha beta gamma. Okay, already this is given that this is tautology. Now I will try to make it false. I will also try to make it false. If I can do that, if I can make it false, then it means this is not tautology. It means alpha does not infer gamma. And if I can make it false, then beta does not infer gamma. So I can say that option C is false. Okay, so can I make it false? Alpha implies gamma. How can I make it false? Here definitely alpha must be true and gamma must be false. And similarly, how to make beta implies gamma must, okay, then beta must be true and gamma must be false. Okay, now in these situations, can I make this true? Is there any problem? Like, okay, in these situations, is there any problem? No, there is no problem, because okay, this must be tautology. So here you can take beta as false. If you take beta as false, then there is no problem. Just take beta as false. Now definitely this will be true. And similarly here you can take alpha as false. Okay, so what we have done, this is a true, this is a tautology, but you can notice neither this is true nor this is true. So I can say that option C is a false. Okay, so option C is not correct. And what about option D? If alpha infers beta or gamma, then alpha infers beta or alpha infers gamma. Okay, so you can check this also. Now I hope you can do this. If alpha infers beta or gamma, if alpha infers beta or gamma, then alpha infers beta or alpha infers gamma. So this is the question. Again what I will do, the same thing I will do. So this question is already saying that alpha implies beta or gamma, This is already given to you as tautology. This is already given as a tautology. Now, what I will do, I will try to make it false. I will try to make it false means what I will do, alpha implies beta. Okay, I will try to make this non-tautology. I will try to make it false, and I will also try to make it false. So if I can make it false, and also if I can make it false, okay, if for example, if I can make it false, if I can make it false, then I can definitely say that this option D is a false. Again, what I will do, alpha, beta, gamma. Then what I will do here, okay, so here what you can very easily see that okay, so to make it false, what I have to do, alpha must be true and beta must be false, and similarly alpha implies, okay, gamma, that must be false, then alpha must be true and gamma must be false. Now, in these situations, can I make, is there any problem? No, there is no problem, because here you can make gamma true. If you make gamma true, then this is definitely true, and here you make beta true. Okay, so you can easily see that, you can easily see that this is definitely tautology. Alpha implies beta or gamma. This is definitely tautology, but that does not mean that alpha implies beta is also tautology, or alpha implies gamma is also tautology. So this does not mean. So I can say that if alpha infers beta or gamma, then it does not mean that alpha infers beta or alpha infers gamma. It does not mean. So option D is also not correct. So the answer is option A, comma B. Okay. Let's solve this question number 13. This is very simple. Okay, in this question, phi and psi, two formulas are given. So first you simplify them. Whatever is the question, just simplify them. Psi is already given to as negation p. Okay, and what is phi? Phi is p and q bar. Okay, so p and q bar implies pq, implies pq. So let's simplify this. Now we already know that x implies y. You can write it x bar or y. You can write it x bar or y. So what I can do, I can write it pq bar whole bar or pq. Okay, and what is this? This you can apply the De Morgan law. So this will be p bar or q or pq. Okay, now what you can do, this is actually q. Here you can apply the absorption law. So the absorption law says that x or xy, this is simply same as x. So this will be p bar or q. Okay, so this will, now this is phi. You remember, this is phi and psi is p bar. Now the question is saying that phi is logical consequence of psi. Now we have already seen that what it means. If I say x is logical consequence of y, what it simply means, if I say that x is logically consequence of y, what it simply means, what this statement means, let's see. X is a logical consequence of y, what it means, it means that y implies x is tautology. It simply means y implies x is a tautology. This we already know. Basically, x is logical consequence of y. It simply means that y implies x. I can say that y implies x is a tautology. Okay, I can also say that, okay, y infers x. Okay, so both these things, all these things are same. X is logical consequence of y, that simply means that y implies x. Now the option A is saying, let's see who is logical consequence of whom. So here we have, so finally the phi that we have, that is p bar or q. Phi is p bar or q and psi is p bar. Okay, so let's see who is logical consequence of whom. So let's check whether phi implies psi is tautology. Is it tautology, or psi implies phi is tautology? Which of them is tautology? Just check it. Okay, so p bar or q, this is actually, this is same as p implies q. So can I say that p implies q implies p bar? Is it tautology? Okay, also check p implies q, is it tautology? Which of them is tautology? Then definitely you can let's check whether it is tautology or not. So this you can write, what you can do here, this is actually same as, you can do the simplification. So it will become p bar or p, okay, this will become p, or this will become p or p bar or q. So this is actually true, this is actually true. So I can say that this is definitely tautology, this is definitely tautology. And similarly you can simplify this one. Okay, p implies q implies p bar. So let's simplify this, what it will become. So this will become that p implies q whole bar or p bar. Now internally what it will become, Internally I can say that this will become p bar or q whole bar or p bar, and you can apply the De Morgan law, then that will become p and q bar or p bar. And you, okay, here you can use this rule that x or x bar y. So what we can do in this situation, we can remove this x bar, we can remove this x bar. So here what we can do, p bar or q bar. But definitely this is not equivalent to true. I can say this is definitely not equivalent to true. So this is not tautology. So I can say that this is definitely not tautology. Okay, here this is definitely not tautology. So I can say that this is tautology. Psi implies phi is tautology. So I can say phi is logical consequence of psi. Phi is a logical consequence of the formula psi. So option A is correct. Okay, let's see the next question. This is another question, question number 14. So which of the following logical consequences are correct? Okay, so you can just check it out. This is another simple question. Let me take few options. Option A, is this logical consequence correct? Option A is saying that P implies Q, P implies Q infers negation P implies negation Q, negation P implies negation Q. Is it correct? Can I say this will infer negation P implies negation Q? Okay, so you can very easily see this is not correct. So I can say this definitely, remember this is the original statement, this is the inverse of P comma Q. If you remember, this is actually inverse of, this is inverse of P implies Q. And here I can say that this does not infer this. Why? Because P implies Q, what you can do, just think about it. If you make it like, if you make it false, if you make it true, P is false, Q is true. In this situation, this will be true. In this situation, this will become true, but this will become false. Okay, so I can say that definitely P implies Q does not infer. I can say what I can say. I can say P implies Q does not infer. Okay, negation P implies negation Q. So definitely, which of them following is correct? This is not correct. Option B is saying that P implies Q. This is option B. P implies Q and P bar. This infers P bar. Okay, so P implies Q and Q bar infers P bar, and Q bar infers P bar. So you can actually think like this. Actually, this type of question, whenever you see this type of question, you can handle like this also. So if I give you like S1, okay, comma S2, comma S3 infers S, then this automatically means that S1, S2, S3, S, this argument is valid. It automatically means that is a valid argument. So if S1, S2, S3 they infer S, then it automatically means that this is a valid argument. So you can check the validity of argument also. Is a valid argument. So here in this question, what you can do, similarly here what you can do, you can just check the validity of argument. P implies Q, Q bar, then can I say P bar? Is it valid argument? Okay, P implies Q, Q bar, then P bar. Yes, this is valid argument. This is modus tollens. This is known as modus tollens, and this is a valid argument. You can check this is a valid argument. We can also see that, see, P implies Q and Q bar means Q is false. See, if Q is false, just think about it. If Q is false, then definitely P must be false. So definitely P must be false. So this is the idea. Remember, this is a very simple idea that this statement S1 and S2 and S3 and S4 infers S. Okay, this is the same as, I can say this is the same as S1 comma S2 comma S3 comma S4 infers S, and this is the same as, this thing is same as, I can say S1 and S2 and S3 and S4 implies S is tautology, implies S is a tautology, and this thing is same as, again you can notice this thing is same as, this statement is same as I can write here S1, S2, S3, S4, S. This argument is valid, is a valid argument. All these things are same. Okay, so all these things are same actually. This first one, second one, this third one, and this fourth one. All these things are same. So what you can do, you can do like this also. Let's see the question of, so this is a valid, this is definitely, this is a correct inference, this logical consequence is correct. What about option C? P implies Q and R. Okay, so let's see option C. Option C is saying that P implies Q or R. Infers P implies Q and R. P implies Q and R. Infers P implies Q implies R. Okay, P implies Q implies R. So let's check this. Again, this you can think like this. So this is your P implies Q and R. This is the okay, and this, so this is the premise and this is the conclusion. P implies Q implies R. So let's check whether this is valid argument or not. Okay, let's check whether this is valid. So first what you will do, you will try to make it false. So just make it false. If you make it false, first you make the conclusion false. To make the conclusion false, definitely R must be false. If you want to make it false, then R must be false and P implies Q must be true. This must be true. Okay, so P implies Q must be true. Now try to make this true. Try to make only one premise we have. Try to make it true. Remember, R is already false, so this is definitely false. So how can I make this premise true? How can I make this premise true? Remember, Q and R is false. Okay, how to make this premise true? I can make P false. I can definitely make P false. Yes, I can make P false, so I can make P false. So definitely I can say that this is invalid argument, because after making conclusion false, I have created all the premises true. There is only one premise. So after making conclusion false, I have created the premise true. So I can say that this is definitely, so option C is definitely wrong. So this does not infer this. So I can say this is definitely wrong. Okay, so option C is definitely not correct. Okay, and next, okay, the last one also you can very easily handle. So option D, let me check option D. Okay, so what option D is saying? P or negation Q and R. Okay, this is saying P or negation Q and R infers, negation Q and R infers, okay, infers Q or negation R implies P. Q or negation R implies P. So this is the statement that is given to you. Now let us check it. So again the same thing you can do. So let's check whether this is valid argument or not. So what you will do, just make it false. How to make it false? There is only, okay, so P must be false. P must be false and Q or R bar, this must be true. So P, okay, P must be false and I can say Q or R bar, that must be true. Now P is already false. Remember, P is already false. Now I will try to make it true and P is already false. Can I make it true? Okay, can I make it true? Remember, Q or R bar is true. Then can I make this true? Let me check this. Okay, so how to make this true? How to make this true? Can I make this true? How to make this true? To make this true, R must be true. To make this true, R must be true and Q must be false. R must be true, Q must be false. But that there is a contradiction, because remember, Q or R bar must be true. Q or R bar must be true. Then I can never make it true. I can never cannot be true. This cannot be true. Whatever you do, this cannot be true. So I can say this is a valid argument. I can say this is definitely a valid argument, because after making the conclusion false, I cannot make all the premises true. So this is a valid argument. So I can say option D is actually correct, because this is a valid argument. So this is correct. So answer will be option B comma D. Okay, so this is your last question. Okay, so this is the last question actually. This is the last question of the quiz, question number 15. And this is another very easy question. PQR, these are the three propositions are given to you. Okay, Paolo is happy. Q means Paolo paints a picture. R means Renzo is happy. Now these three statements are given to you, X, Y, Z. So just write them in the propositional language. So what this will become? If Paolo is happy and paints a picture, then Renzo isn't happy. So what X means? X simply means that if Paolo is happy and paints a picture, then Renzo is not happy. Okay, so this is your X. This is the statement X, you can notice. Okay, and what is statement Y? Statement Y, what is that? If Paolo is happy, then she paints a picture. And what is this statement? Paolo is happy only if she paints a picture. So this also will become, so actually Y comma Z, they are basically P implies Q. Both are P implies Q. Y comma Z, both are P implies Q. So I can say Y comma Z you can match, okay, with 2. And remember, what is this? This is same as, if you notice that this will be P bar or Q. And this is same as P implies Q. So here you can notice that 2 is equivalent to 3 and Y is equivalent to Z. Y is equivalent to Z and they are equivalent to 2 comma 3. So Y Z they are equivalent to 2 comma 3 and X is equivalent to 1. Okay, so finally I can say X should match with 1. X should definitely match with 1. Okay, and Y comma Z they can match with 2 comma 3. They can match with 2 comma 3. So this is correct. This is correct. Okay, so answer will be option A comma C. So these are the solutions of weekly quiz 3. If anyone has any doubt, you can ask in the comments. Okay, so any doubt you can discuss on the Gate Overflow website also. So if there is any doubt in any question, just write your comment and we will answer it. Okay, so this is the weekly quiz 5 solutions. Okay.